this is the idea about MySQL transaction. So when you will be talking about an example, I'm sure you can see that the same example in our examples. Okay. Good. So let's move forward to the next slide. So a bank transaction scenario, that's our next example. And I just talked about that. Let's listen the text.
Bank transaction will be best example for explaining this. Consider a transfer between two accounts. To achieve this, you have to write SQL statements that do the following. Check the availability of requested amount in the first account. Deduct requested amount from first account. Deposit it in second account. If any one these process fails, the whole should be reverted to their previous state.
Right. So you can see there are 3 steps while transferring balance from one account to another account. So first checking is the account providing the money must have the enough there. So if you initiate and transfer the $1,000, but your account has $900, so that will never take place. So that's the idea. That's requested amount first be available in the first account. Second time, if there is enough, then it will do the deduction. And the deducted money will be in a transfer process, and your account need an update that you deducted this. So if you have $1,000 and if you transfer 900, then it will update that amount to 100. Then the deposit the transferred money to the account B or new account. So this is the whole idea. But in these 3 steps, any of the step has error, the whole step will be go back to its initial states. That's the whole idea of transaction, bank transaction, or MySQL transaction. Now it is talking about acid property of transactions. So the 3 steps example will maintain all those acid or ACID, means atomicity, consistency, isolation, and durability properties. So let's see what are those.
MySQL supports the ACID properties for a transaction-safe relational database management system. Atomicity ensures that all operations within the work unit are completed successfully, otherwise, the transaction is aborted at the point of failure, and previous operations are rolled back to their former state. Consistency ensures that the database properly changes states upon a successfully committed transaction. Isolation enables transactions to operate independently of and transparent to each other. Durability ensures that the result or effect of a committed transaction persists in case of a system failure.
Right. So these acid properties are very important, and I can show you a few things here. Rollback, you can see here, and we'll see some MySQL command on rollback, right? And this is committed, so we'll see a keyword like commit, and we'll see another keyword like rollback. And if, as it says in durability, ensures that the results or effect of a committed transaction persists in case of a system failure. So if there is a system failure, it actually rolls back to an initial state. If it is successful, then it will actually commit it. So it will complete the transaction and update all the values in that transfer accounts, that the accounts involved in that money transfer process, the earlier example in the earlier slide. Okay. Now let's go back. Let's go to the next slide and that talk about MySQL transaction syntax. So this is a general form, and as we mentioned in the definition that transaction is a collection of MySQL sentences or statements. And the end, it will either be committed, means commit, or it will be rolled back to its initial state. So this is the general form of MySQL transaction statements. And transactions begin with a start transaction or begin work, but most books follow this start transaction. So I added this begin work just for convenience so that you know, but if you don't like to use it, you don't need to use it. Start transaction make more sense to me as well. And end with either a commit or a rollback. So either if it is commit, then it's successful. If it is rollback, that means the transaction process is not successful. Okay. So again, this banking example, and we'll execute this code. So transaction example, bank account. A person holding account A is trying to transfer $100 to account B. So let's create a table, right? And transfer, insert some values in this bank account. So I'm going to this XAMPP folder. I'm choosing DB1 and go in MySQL. Pasting this code, and I'm creating this bank accounts. Maybe I can make it a little bigger. Bank accounts table and inserting two values there. Okay. So I hope it's created this bank accounts, and I can see account 1 and has $1,000 and account 2 has $1,000. So this thing is done. Let's move forward to next slide. And this transaction example is continued. And now start a transaction. And see here, the transaction starts with a start transaction statement. Now, because transaction took place in update, insert, update, like any modification of DML, means data manipulation language part of SQL. So here we are showing the update. And after update, we ask the system to commit. And it is taking the fund 1,000 from account 1 and adding it to the account 2. This account 2. So let's copy the code. Do you know how to transfer, how to make this text bigger? Is there any options in the font size? I don't know, there should be. I never thought of it, but there should be some. Okay. I'm sure there is. I'll have a look later. If I can make this font size bigger, then we can see easily. Okay, so start transaction, then update the account. So we are taking off $100 from account 1 and putting $100 in account 2. And then the commit. Let's go. And let's check these bank accounts. And you can see this amount is transferred from account A to account B. So, and it's committed, right? So let's go back. So here, start transaction, this line indicates MySQL to begin or initiate a transaction process. Statements that need to be executed. So this is the body of the transaction. And then the commit. So either commit or rollback. In this case, we choose commit because we don't want rollback. Now we already saw this, that the account has $1,000 each. Now after transaction, the transfer took place and account 1 has 900 and account 2 has $1,100. Now let's talk about rollback, right? So we would use the same transaction to debit account 1 and credit account 2 with a fund of $100. Now, if you like to roll back this, and what happened? We are making another transaction and transferring $100 again. So now let's check the status. So it has 900 and 1100. And we are trying to make a transfer, but we said rollback instead of commit. So let's transfer, do the transfer and run this code. Now let's check the account, right? And you can see a green here. MySQL returned an empty result 0, query this, and statement rollback successfully executed. So let's click here. So although we did the transfer and asked them to roll it back, so here is 900 still, right? So this is rollback. Now let's run again with the commit. And let's see what happened. Let's go back here and see 800. So you can see that how commit and rollback works. So I can take a pause here and wait. Yeah, thanks so much. So you understand the how to turn on or turn off the auto commit state of the auto commit operation of MySQL server. So let's go back to the slide again. So the key idea is, by default, the auto commit is always on in MySQL server. Okay, let's go back here. This is another example about an airline. So in this example, let's read the text, then we'll start to talk. Okay.
Suppose that a flight table contains information about airline flight schedules and you want to update the row for flight 578 by choosing a pilot from among those available. You might do so using 3 statements as follows.
So set this pilot available, select pilot ID from pilot where available, yes, limit 1. So you can see this limit is a keyword and one pilot cannot be assigned more than 1 flight. So that's why it says limit 1. This is an integrity checking. In the second statement, update pilot, set available, know where pilot ID is pilot available. And update flight set pilot ID at pilot variable where pilot ID is 570. So this SQL is trying to assign a pilot that ID is 570 for a flight. Now, say this example is interesting. And say there is a flight here and there is a pilot here. P1, P2, P3. So say P2 is available. Now, and P3 also available, okay? Available and available. Now, when you go in a big database, say multiple operator probably working. And if multiple operator working, maybe one operator trying to assign this is flight 1 to pilot 2 here, and pilot 3 here. So that's why we need a transaction so that when someone already took over, say agent 1 and agent 2, or maybe programmer 1 or programmer 2 trying to a pilot to a flight, then this process will be blocked, and until this transaction is not finished, the another transaction cannot take over this resource or this column or this row, whatever, on a certain record. So see, not only banking, for many other applications, transaction is very important to maintain the atomicity, so the acid property, atomicity of your database. I hope this example makes sense to you. Okay. So the first statement choose an available pilot. The second statement makes the pilot as unavailable, and the third assignment pilot to third assigns the pilot to a flight. So if any pilot is unavailable, then there is no way we can assign them. And the transaction or the SQL statement will end up with a rollback, means no status will be changed for that pilot because he is not available and we cannot assign that pilot for a flight. But if someone is available and agent 1 or multiple agent working, then we need a transaction. And as soon as a transaction started to take place, the other transaction will not be available, or other agent will not able to access this flight to assign a pilot. Now in this lecture, I didn't go or didn't talk about locking much, but this is called locking. But I have an example, is concurrency control. Concurrency means when one record is accessed by multiple programmer or multiple agent, then it creates an concurrency situation, and transaction needs to control that concurrency in a sequential way. So multiple people cannot modify the same record at a single time. That's the idea for transaction. Let's move forward. And you can see this slide talked about concurrency and integrity. So concurrency and integrity is very important. And if the integrity property is true, and integrity is actually all those 4 things, ACID, these 4 properties create the integrity. Okay. And concurrency is the work done by multiple process, by multiple operators or programmers or whatever, by multiple agents. So let's see what is concurrency or concurrency issue talked about.
If 2 clients want to schedule pilots, it's possible for both to run the initial select query and retrieve the same pilot ID number before either has a chance to set the pilot's status to unavailable. If that happens, the same pilot is scheduled for 2 flights at once.
Right. So as soon as you assign a pilot to a flight, you have to turn his status unavailable. Otherwise, other person might take that pilot to assign for the same flight or another flight. So we need to maintain an integrity in concurrency work, because if a pilot is assigned a flight, his status must be unavailable as soon as that pilot assigned for a flight. So there should not be any concurrency issue to maintain the database integrity. And let's talk about integrity issues.
All three statements must execute successfully as a unit. For example, if the select and the first update run successfully, but the second update fails, the pilot's status is set to unavailable without the pilot being assigned a flight. The database becomes inconsistent.
Right. So all three statements must execute successfully as a unit. For example, if the select and the update run successfully, but the second update fails, means if you go back to this slide, the airline example. So this one, the pilot is available, right? Now, of course, for a single flight, that guy cannot be assigned for multiple. So this statement executed correctly. Now we have to update the status of the pilot. No means unavailable, because we are planning to assign him to a flight number 578. So if this statement fails, then the total transaction, or this statement segment, that's the body of a transaction, must roll back to its initial state, and the pilot will be still available, although this statement's trying to make the pilot unavailable because he's supposed to assign there. But if the third statement didn't successful, then this no status will be rolled back to yes, means available status. I hope you understand. This is an example. Okay. So the concurrency is the idea when multiple process try to access a single record to do some update operation. That's concurrency. So to maintain the concurrency, we need to look for database integrity, and that's the ACID property. So if all are not successful, it will roll back. That's the whole idea. Okay. So the transaction prevents concurrency and integrity problem. So this is the key thing about concurrency and integrity. So concurrency might create problem because multiple agents working to access the same record. The shopping example I give you at the beginning, that I have $500, but two of us trying to breach the banking system and do the shopping at the same time. But as soon as one assignment, one process took place, the bank account, the other process will be on hold, so that the integrity of the database is maintained. So there is a concurrency, but it will be sequential.
No other client can update the data used in the transaction while the transaction is in progress. For example, other clients cannot modify the pilot or flight records while you're booking a pilot for a flight. Transactions solve concurrency problems arising from the multiple client nature of the MySQL server. In effect, transactions serialize access to a shared resource across multiple statement operations.
Right. So this slide is very important. Here we can see it says multiple client nature of MySQL server. Do you know what does it mean by multiple client nature of MySQL server? Anybody? This is an interesting concept. That's why I stopped sharing my screen and turn on my camera. Now, how many of you familiar with multi-threaded? So MySQL is a multi-threaded database system. So multiple clients can work with the same table, same database at the same time, and this process is called concurrency. But concurrency might create problem if two clients try to update a single record at a single time, and the data integrity might be compromised. The solution is transaction. So as soon as one client is started to process a record, the transaction process block the other clients to interact with the same record or the same table. As soon as the client one finished working, then client two got access. And this is the whole about the transaction. I hope that makes sense now to you. Okay, let's go.
Yes, Professor.
Yeah, thank you. Let's go share the screen again. So this is a key information here that MySQL is a multi-threaded SQL server. And the transaction process prevent concurrency issues and maintain integrity in your database. Okay, let's again read this using our machine.
Statements grouped within a transaction are committed, take effect, as a unit, but only if they all succeed. If an error occurs, any actions that occurred prior to the error are rolled back, leaving the relevant tables unaffected as though none of the statements had been executed. This keeps the database from becoming inconsistent. For example, if an update to the flights table fails, rollback causes the change to the pilots table to be undone, leaving the pilot still available. Rollback frees you from having to figure out how to undo a partially completed operation yourself.
Right, so this slide is a review process that if all the statements in a transaction successfully executed, then the process will be committed, otherwise it will be rolled back. Okay, so we are moving forward to MySQL index. At this phase, do you have any question about MySQL? I believe recording is on, I believe. Yes.
Indexes are used to find rows with specific column values quickly. Without an index, MySQL must begin with the first row and then read through the entire table to find the relevant rows. The larger the table, the more this costs. If the table has an index for the columns in question, MySQL can quickly determine the position to seek to in the middle of the data file without having to look at all the data. This is much faster than reading every row sequentially.
Now, I know all of you know what is primary key, and primary key is unique for every record in a MySQL table. Now, why do we need index? So if you have a table very big, like containing thousands, hundreds of thousands of records, then using primary key is, of course, we need it to maintain database integrity because we want to make records unique for our easier processing and avoid duplication. That is correct. But say if you have a huge data set, database, and the tables has thousands of records or even hundreds of records, now finding those records is very expensive in terms of time and using the SQL server, because if you use only primary key to find a record, to modify, delete, or whatever, or just for display, it will actually traverse the whole table sequentially until it don't get that file. So in that case, even some queries might be, it need to access the whole column, because say you like to find a certain group of people has the salary limit with from 1 to like of a certain amount range. to avoid this, we can actually set index in with the column names, and it will make give us the opportunity to search the big tables or database quickly by using index. But it doesn't mean if you have index, you don't need primary key. Rather, primary key is creating an index by default. But MySQL index is an additional index or pointer to the table, and indexes are associated with certain table. This is very important to remember. Now, how do we create this index? So this is the general syntax for creating index. Create unique. Unique is an optional keyword. So if you like to define an index, you can create that unique index is unique, or you can just don't say it is not unique. If index is unique, then it cannot take the repeated, it cannot take the duplicate value in the same column. But if you don't choose unique, then that column might have multiple record with the same duplication thing. So it is based on the nature of the table that you will be using, or you will be defining the index, whether you want an unique index or you want a regular index. I'm telling it regular index, like, or non-unique index rather. That's more appropriate. So create index name on, this is database, so database name and table name. So again, this unique index is associated with the table. This is very important. And then you should choose the column name, whether index is associated with one column or more than one column. So now there is a trade-off. This index is giving us the opportunity to find the records more easily compared to the faster way compared to the primary key, right, or the foreign key. And now index is only is a good tool if you have a very large table. If for a smaller table, I believe we have enough computer power to find a record from a small database or table. So this is the concept of indexes. Now we're going to watch a video, and this video will give us more ideas about MySQL. So in the meantime, while watching video, I might take a pause, or if you have any question, you can take a note, and after video, we can address those questions. So this video will talk about MySQL index. So I'm going to play this video now.
Okay, our next MySQL topic is indexes. So what is an index? If you imagine the database tables that you're working with having hundreds of thousands or millions of records inside of them, it can take a fair bit of processing. Okay, our next MySQL topic is indexes. So what is an index? If you imagine the database tables that you're working with having hundreds of thousands or millions of records inside of them, it can take a fair bit of processing power to be able to find things when you apply a filter, when you're doing a join between tables. So in order to help out the database, we're going to create an index which really tells the database, this is a really important column. I want you to remember sort of where different ranges of things are inside that column. Where can you find the number 72 inside that column? Where can you find the number 1008 inside that column? So it's highlighting what's really important. So it can create this sort of tree structure which will help it be more efficient to search through that table when you run your queries. Now, don't worry about the tree structure. Don't worry about how it's working internally. What we're going to do here is just look at how to create an index and how to add that into our code. Okay, so this is the reference right here. I'm going to provide this link inside the description for you on how to create an index. There's actually a few different ways that we can do it. You can create an index when you're creating the table. That's actually sort of the preferred way to do it. But if your table already exists, you can add other indexes as long as it's not a primary key. You can use the alter table syntax to add a key, or you can just run a create index command all on its own. So I'm going to work with the database that I've got created, but I'm not going to work with any of these tables. I'm going to create a brand new table. We're going to look at all three of these methods. So inside my database, I'm going to create a new table. I'm going to call it products. So I'll say create table products. And then we have our parentheses. And at the end of that, we'll say the engine's going to be InnoDB. Okay, so there's the basic create table command.
Now you can see in this command like this InnoDB, right? So it's InnoDB engine equal to InnoDB. So there are two types of engine. So when you are going to talk about database management or the administrative part of a database, you are going to talk about those different data engines. But this is an optional part. You can choose either InnoBD or IESAM. But again, the database engine might have a different MySQL commands. So InnoDB is by default when you install your XAMPP. By default, the engine is set as InnoDB. So if you don't add this statement that engine equal to InnoDB, by default it will be InnoDB, even though if you don't define. So I hope this concept helped you. Thank you.
Now inside of here, what we want to do is create the columns. Now there's nothing new about this, so I'm just going to fast forward through this. I'll skip over it and stop when I've got the columns created. Okay, so I finished typing that out. We're creating the products table, and we're going to have these 6 columns: product ID, name, category, price, SKU, and a short description field. So product ID, this is going to be our primary key. We're saying that it's an unsigned integer, it's going to auto increment, and the last line here, we're actually defining it as the primary key. Now this is a type of index. We're saying that this is going to be the unique value for every single row. By making it an integer and auto increment, MySQL is going to take care of it for us. It's going to automatically put in that number whenever we insert a new product. So the name and the category, these are just text fields. The price is a decimal field up to 10 digits with 2 after the decimal place. The SKU is going to be a fixed length char with 10 characters in it. So it's a unique identifier for each product. But it's not our primary key. We're going to add an index to this, and we're going to say that each of these has to be unique, but it's not the primary key for the database. So we do a short description, varchar 500, so it's a big text field if we want to do that. We've put this in here so that we can add a different type of index, a full text index. Okay, so there's my basic description. Now I'm going to add the first key other than primary key in here, because we can do that while we're creating it. This is the first method. Inside of here, I'm going to say index, and then give it a name. So let's say it's names, or IDX names, index names. Then we add a set of parentheses, just like we did on the line above here. And inside here, we can put the one or more fields that we want to use. So I could say product name. Now, when we create the table, it's going to add an index on this one product name column. So it's going to keep track of everything inside of there. If you want, when you create an index like this, you can say you want to do 2 columns, or 3 if you want. Just like that. So it's going to combine these 2 fields to create one index. And you would do this if you were running lots of queries, or if you were predicting that you were going to run a lot of queries where you're filtering on both the product name and the category at the same time. If you're going to do that in your select statements, then this is a good index to create, because, okay, maybe they're going to ask about the product name, maybe it's going to be the name and the category, but very rarely will you do just the category. If that's the circumstances, then this is a great index for you to create. Okay, so let's do this. Let's run that. Okay, so that worked just fine. Now let's take a look at the table. Here's products, and we'll take a look at the structure inside of there. So we've got our columns. Those were created just fine. Nothing new about that. Here's our primary key being defined in the section called indexes. And here's the one that we created, the additional one, IDX names. And we can see both columns are included as part of this. And unique is set to no. So we didn't need to necessarily make an insistence that both the name and the category together, those 2 things, have to be unique on every row. It wouldn't make sense to disallow somebody from ever having this 2 products with the same name in the same category. The SKU, however, these are supposed to be unique, so we can add an index on this one and say, yeah, you know what? This has got to be a unique index. So let's take a look at doing that one now. So we'll jump in here, and we can use the second way. The first way was with a create table. Once you've done this, then we can do an alter table products, and we're going to say we're going to add index. Before it was just using the keyword index. So now here, add index. We're going to give it a name. So we're going to do it on the SKU. So let's call it IDX SKU. Now we don't have to put IDX in the underscore. I'm just doing that so I recognize the name. I'm going to follow this naming convention for all my indices. So index SKU, and then it's going to be on the column product SKU. There we go. Now, if you ever do need to get rid of an index that you've created, we can use this command right here. So drop index and then give it the name. So IDX SKU on, and we provide the table name. So this would get rid of the index after we create it. Okay, so add index. This is going to create a normal index on just this one single SKU. So I'll run that. Fair enough. It added that index. If we go back to the structure and we take a look at this, I'm just going to copy that so I can use it again. So here we have it. Now there's another index SKU right here, but we didn't define it as unique. So I want to change this. I want to make this a unique index, just to say that every single row in there is going to be unique. Okay, I'm going to run just the drop command by itself to get rid of that index. Now it's gone. Now to show you the alternate one, we're going to add index, same as before, IDX SKU. All we're going to change here is this word index. And we're going to change that to say unique. So now we're creating an index, which is going to tell the database it needs to track all the things going into here, but we're also putting a restriction on it to say that every single value in here is supposed to be unique. So let's run that again. There we go. So it did the same thing. It created an index, and if we go back to the structure, down here, there's index name, index SKU, on the column product SKU, and unique is set to yes. All right, two others that we can do. One is a full text, and this is the third type of syntax. So we can do it in the create table, we can do it in the alter table, or if you want, you can just use the command create index all on its own. So we can create an index. Let's just call it IDX text on products. That's our table. We have to specify that. When we're not doing a create table or an alter table, we do have to specify which one that we're creating it on. So on products, and then inside the brackets, we're going to use the column short description, just like that. Now this would create a regular one. If I change that to unique, it's going to create a unique one, but I don't want to try and put a unique restriction on a description field. So I'm going to make this a full text. It's a different type of index. For full text, we should keep the word index in front of that, or after that rather. So we're creating a full text index on this text field, on the table products, on this column. So all those things together will create this other index for us. There we go. Created that one. Go back to structure, take a look, and sure enough, there it is. Now it's the type full text. You have to be very careful with the full text ones. You are dealing with large amounts of text, and if you've got a really big text field with a lot of content on there and you're creating an index on that, you're putting a lot of extra work on the database to do this. You have to consider whether or not you're going to be doing many searches on this. If you're going to be doing a lot of searches on this field, then it might make sense to do an index on this. But you wouldn't ever put indexes on all the fields like I'm doing here. This is really just an example to show you the different kinds of indexes that you can create. Think about what the queries are that you're going to be writing. What data is it that you're going to be searching for inside your table? What filters are you going to be applying to your table? So one last one that I want to show you. So creating an index where we want to search on part of a field. The product SKU is a great example of where we could do this. So I'm going to create an index called IDX SKU 3 on the table products. And then on the column product SKU, but we add an extra set of parentheses here, and then I can put in the number of characters that I want to use. So what I'm doing is I'm actually creating an index on just the first 3 characters of this char field. So I know, okay, maybe the first 3 characters of the product SKU indicates what category it belongs to or what type of product it is. And maybe this is the kind of lookup that I'm going to be doing all the time. So I want to create this special kind of index where the first 3 characters are what I'm going to be looking at all the time. This is going to be what it uses when it does the sorting and searching. So I run that, and there we go. So it's that last little set of parentheses that we can put on the column name, which will define how many of the characters starting at the very beginning that we want to add this index to. All right, so that gives us the ability with create table, alter table, or just on its own to do create index. We can do drop index as well to get rid of them. And there are those 4 different kind of indexes. We've got primary, unique, just a regular index, and a full text index. So you've got those 4 kinds that you can play with to optimize. And that is really the purpose of an index. It's to optimize when you're running your queries. Don't just arbitrarily go through and add indexes like this. I mean, on a table that's only got 6 columns, I shouldn't really have 5 indexes. I mean, sure, I'm going to make a search extremely efficient regardless of what search it is that I'm doing, but I've added all this extra overhead, so every time there's more columns being added or more rows being added, Every time there's new data going into that table, I'm forcing MySQL to go through and redo its indexes. It has to go through and recreate all these indexes to make sure that it can do these searches. And all the extra data that's being stored in these indexes as well, it's creating this extra information off on the side to be able to do the searches faster. So you have to weigh that when you're working with indexes. So I hope that makes sense. I will leave the link to the Create Index page inside the reference. I'll leave another link for the entire MySQL playlist. And as always, thanks for watching.
All right, so let me stop this. Okay. So we are running this lecture. We started at 1:10, say, and it's almost 1 hour and 10 minutes. So one more slide, then I'm going to take a break for 10 minutes, and I will ask you to see the video again, and then I will explain the index, few other different thing in index, because there is no slide for index. So I'll go through the video and explain you well. If you have any question, please take a note. Now, the obvious question, the reason for adding this slide is to understand between primary index and secondary index. So in this video, you heard about 4 kinds of indexes. The index means just the simple index or general index, primary index, index with a keyword unique, and full text. Now I'm going to give you an explanation, but again, the primary index, what is primary index? Primary index actually the primary key for your table. And this is the difference between primary index and the secondary indexes. So the all other indexes we are creating are actually secondary indexes. Whatever it is, full text or unique index, all are secondary indexes. So it's the primary index. Index on a set of fields that includes the unique primary key and is guaranteed not to contain duplicates of record. So you understand, this statement is telling you unique primary key. So includes the unique primary key. Say you don't want to create a primary index, but you want to create a primary key. That's actually your primary index. On the other hand, secondary index is index that is not a primary index and may have duplicates. So that's non-unique property. Requires the row in data blocks to be ordered on the index key. Does not have an impact on how the rows are actually organized in a data block. So this is a sorting thing. There is only one primary index. So see, if you create a primary key, that's your primary index. There can be multiple secondary indexes, as you saw, like you can create the secondary index with multiple columns, with multiple name and different types, like full text index. And I like to talk about full text index, then we have to talk about the data type again. I'm going to explain those after taking break. I'm sure it is already too much for you. The last thing is there is no duplicates in the primary key, means the primary index. So no duplication. There can be duplicates in the secondary index. So it could be possible because we are not mentioning it as unique. So this is the difference, but in a nutshell, your primary key is your primary index and secondary indexes are all other indexes. I hope you have some idea about. Any last question?
Sir, assignment thing.
Oh, assignment, yes.